In this video, we will continue our discussion on the Singapore Junior Physics Olympiad 2013 General Round paper. Question 7. A small graphite block stays at rest on a piece of paper. The piece of paper is now moved and both the paper and the block move at the same constant velocity v sub 0 horizontally. After moving for a time t, the paper stops suddenly. Given that the kinetic friction between the graphite block and the paper is mu, what is the length of the marking that the block made on the piece of paper when the graphite block eventually stops? Assume that the mass loss of the graphite block is negligible throughout its motion. To answer this question, we can start by invoking Newton's first law of motion. It states that a massive object at rest tends to stay at rest, and a massive object in motion tends to stay in motion unless acted upon by an external force. We can thus say that at the instant the paper stops, the velocity of the graphite block must be v sub 0. After the paper stops, only the mutual friction between the graphite block and the paper contributes to slowing the block down. The path marked out as it slides across the paper would therefore form the length of distance travelled. We thus use the constitutive equation for kinetic friction, namely that the kinetic friction is equivalent to the coefficient of kinetic friction multiplied by the normal contact force acting on the block. We suppose that the paper and block are situated on a flat surface, allowing us to say that the normal force N is equal to the weight of the block mg. Combining the two equations, we know that the kinetic friction acting on the block forms the net force acting on the block, and is given by the coefficient of kinetic friction multiplied by the weight mg. We invoke the work energy theorem, which states that the change of the kinetic energy of the block is equivalent to the net force acting on the block summed up over the distance that is acting. This is also equivalent to half m times the initial velocity squared of the block minus its final velocity squared, which is 0. Therefore, the distance travelled by the graphite block before it comes to a complete stop, at which the kinetic friction stops acting, is delta S equals to v sub 0 squared divided by 2 mu g. If we look back at the question, this means that A is the correct answer.